joining us. So we are going to be discussing the innovative future of advanced material simulation, which is a fascinating topic. We are the Jobber team. So an introduction for the uninitiated. Advanced materials are effectively the production of new or modified materials for specific application purposes. This spans a wide gamut of industries and applications, everything from the creative technologies, including ceramics, biomaterials, nanotechnologies, and the creation of technologies like lasers, liquid crystal displays, and many others. It really touches a wide gamut of industries. So the problem that we're trying to fix here is that the R&D timelines for new materials from initial research to first use are generally around 10 to 20 years, which is very cost and time intensive.
No one can hear me?
Yeah.
Okay. And so, in the case of the construction industry, which is a primary polluter these days, and we are trying to tackle as many sustainability issues as we can, they account for around 62% of the total waste in the UK. So we're looking to solve a lot of these sustainability issues by creating the next generation of new sustainable materials for commercial, like construction, and deep tech applications like lasers and that sort of thing. So again, this really is a very wide spectrum problem. While advanced material simulation might seem like a small field, it does funnel down into almost every conceivable industrial application and industrial field that you can imagine, from food and agriculture all the way to mining. Now, our solution is Jabber, which is a SaaS platform, and it is based around an advanced material simulation enterprise platform powered by ML and data science. So where in the past, advanced material design and material science in general is really a domain of physics and chemistry, we're innovating and bringing it into the future of data science and artificial intelligence. So we're going to really, our technology hinges on the elite data sets that are available to us now in the big data era. So that involves all of the properties of different materials. With our platform, and by not having to physically prototype, we're able to reduce R&D timelines in these fields by about 50 to 75%, from 10 to 20 years to 3 to 5 years in certain applications. This also reduces the prototyping waste, the physical prototyping waste, by about 80%. So, really Jabber is a new paradigm in terms of material science and all of the industries it touches downstream from it. We're using all of the innovative technologies available to us, from artificial intelligence, cloud architecture, all the way to data analytics, to bring sustainable new materials to the future in a quick and scalable format. So I'm going to be handing off to Pedro to talk about technology trends.
So yeah, just going over the technology trends. Material informatics is the term that is used to refer to the use of computation and statistics applied to material science. It's not a new concept. It was first coined in 1999, but it is a rapidly growing field, mostly due to the advancements of all surrounding technologies, such as big data, data infrastructure, and cloud-based tech, and artificial intelligence and machine learning. So we have seen large advancements in these fields due to the growth of computational resources and the creation of specialized applications for AI, and that has unlocked great potential within the materials informatics sector, and also due to the necessity for new materials, more sustainable materials, which have been advancing the material science field in general. So although it's not a new technology, the widespread adoption still faces some challenges. So there are like 3 pillars. The first is skills. So material science researchers are not necessarily well versed in statistics and data science. And so this is, of course, key for material informatics. There are also culture issues. So material science is still really driven by the traditional scientific approach of having a hypothesis and testing it and then iterating over it. And the cost for initial implementation of these new software tools is still can be high. And of course, the data. So you need the data to train the machine learning algorithms. And although there are some open access repositories of data, most of the data on properties for materials is still confined within specific research institutions. So that's why we offer a simple, intuitive platform with a low barrier of entry and the use of proprietary data. Our business model is essentially subscription-based SaaS platform, like Jake mentioned, focused on R&D teams in material science research. We will offer that solution via a low-code graphic interface that will help material scientists who are not well versed in AI or ML. And we are hoping to partner with research institutions to collect and organize their data to use that to train our algorithms and improve our product. So I'll hand over to Varun. He will talk a little about the ecosystem.
Thanks, Pedro. All right, so I'll just go over our ecosystem model, starting right here at Imperial. So from Imperial, we would be getting the IP, the expertise of the professors, as well as the equipment in exchange for access to our data sets that are unique to Imperial, as well as access to our partners. So we would also be partnering with companies like DeepMind Materials Projects, as well as institutions like NTU and MIT. And again, we would be looking to get their programming advances, networks, and the open data in exchange for access to our API. We would have suppliers such as AWS, Cisco, Azure. Since we're a SaaS platform, we need the cloud services, the server infrastructure, cybersecurity, and so on. Moving on to our complementers, they would be companies like Desktop Metal and Nubru. And the way they come in here is if a customer using a simulation software wants to actually prototype a particular material, but they don't have in-house capabilities to do it. So we would redirect them to one of our complementers and they could help them actually prototype it. We would also be partnering with adoption services companies like Henry Harbin, where we would certify trainers at Henry Harbin who would then in turn be able to train employees at companies. And coming to the most important people, our customers, we would be offering them our simulation service software, again, in exchange for a certain amount of money. So this is a possible application of our software. And this is specifically at UT Austin, where they're trying to do research to find alternates for lithium. And they're doing this by combining sodium with elements like antimony, but they expect this to take 10 to 15 years to produce. But we feel with our software, they could bring that timeline down to 3 to 5 years, reduce cost, as well as material waste. Now I'll just go over some risks that are associated with our technology. So the number one would be accuracy. Is our ML algorithm giving accurate results? Concurrency. Can our system handle multiple people working on the same project? And scalability. Let's say we go from 100 to 10,000 requests within a span of an hour. Can our system scale up effectively? So we have experiments designed for all of these, and the combined cost for them is about £35,000. So now I'll hand over to Saud, and he'll be going over some of the market risks.
Thank you very much. So, hello everybody. So our market de-risking strategies revolve around three main themes, which is time, cost, and interface. Our ultimate aim is to leverage the software to reduce time and cost spent on physical experiments. We will also conduct end user surveys to ensure user friendliness. And that is basically the main experiments that we will be conducting. So I'll hand it over to Aish.
Thank you, Saud. Considering the time constraints, I'll try to be as soon as possible. So I'm here to talk about the next steps. So next, we are planning to conduct surveys to know the desirability of a product. And after identifying the interested customers, we are planning to run test runs and to know their complaints, know their recommendations, and make changes accordingly. Thereon, we'll finally launch our product in the market and procure our first valuable customers. And thereon, we're planning to iterate on the product, continue to source ML data and clients' feedback. Our milestones. Our financial goal in the short run is to establish a corporate setup with enough trained employees to provide better services to our customers. And we're estimating a market size at present to be around £150 million. And we aim to capture a market size of 5%. And in the long run, we want to scale up our revenue to a 300% increase, employees to around 250 employees. And we're estimating market size of around £1 billion and to capture a market to 15% by the year to 2028. And our technological goals in the short run is to ensure smooth operations of our software and to troubleshoot the problems of our customers. And in the long run, we're planning to be recognized as an industry-leading data set and ML model corporation, and thereby licensing our API to generate additional revenues. And what we're here to ask for,
So
just
go ahead.
last bit.
You can leave the slide up if you like, but you should stop now. It's already been over 10 minutes. So
Just what we are here.
leave the slide and let's go straight